In this exam question, we have an 8 kilogram block P, which is being pulled by a constant force F up a rough inclined plane at an angle of 30 degrees to the horizontal at a constant speed. Force F is parallel to the inclined plane as shown in the diagram below. Now, the wording that is important here is the fact that we have a constant force and a constant speed. Now, the constant speed is telling me that when we look at Newton's second law, the acceleration would be equal to 0. So the net forces in the direction of motion need to equal 0. It was also said that we have a rough inclined plane, and since we are moving up the slope, the friction would be downwards. Now, in order for me to solve this problem, I'm going to draw all the forces on my diagram. Now I can see that in my direction of motion, I have friction downwards, Fg parallel, which is the component parallel to the slope downwards of gravity, and the force applied. 2.1.1 asks to state Newton's first law in words. Two point 1.2 asks to draw a labeled free body diagram of the block P. Now, whenever blocks are on an incline, it is very important to use that incline, which you can go and draw in a pencil. A free body diagram, remember the free body diagram has the dot in the middle with the vector forces showing outward. Here we have a normal force, gravity, friction down the slope, and my applied force up the slope. Now note that 2.1.2 counts a total of 4 marks. This is always an indication of the amount of vectors that you need to go and draw. You could have also gone and draw the components of gravity, which would be Fg parallel and Fg perpendicular. So if you want to include the gravitational vector as well as its components, make sure that you draw the components in a pencil or use dotted lines. The next part tells us that the kinetic frictional force between the block and the surface of the inclined plane is 20.37 Newton. 2.1.3 asks to calculate the magnitude of force F. Okay, so that's the applied force for a total of 5 marks. Now, in order to solve this problem, I have to make use of my free body diagram. Here I have shown Fg parallel and Fg perpendicular instead of my gravitational force, which should be there. We do this because we do not use gravity when we calculate, but we use the components of gravity, seeing as the components is already in my new x and y plane. We can now simply apply Newton's second law, saying F net is equal to ma, and look at the net forces working in the direction of motion. Seeing as we are moving upward, I have applied force positive and the forces in the opposite direction of motion negative. Seeing as we have a constant velocity, we have 0 acceleration. The frictional force was given as 20.37 Newton, and Fg parallel we can write as mg, which is gravity, the sine of the theta, which gives the total for the applied force as 59.57 Newton. Seeing as they ask for the magnitude of this force, it is no need to indicate a direction, but if you would have said up the slope. In the next part, it is said that force F is now removed and the block accelerates down the plane. The kinetic frictional force remains 20.37 Newton. Now just watch out that the kinetic frictional force will now be in the upward direction, seeing as we are moving downwards. So remember that frictional force is always opposite to the direction of motion. And again, it will be really important here to again go and draw your free body diagram. 2.1.4 asks then to calculate the magnitude of the acceleration of the block for 4 marks. We now have a total of 4 vectors working in on this diagram. We have the normal force, frictional force up the plane, Fg perpendicular as well as Fg parallel still down the plane. Again, we can go and apply Newton's second law, and my direction of motion is downward, Therefore, the vectors moving in the downward direction are positive and the vectors in the opposite direction are negative. Which gives us an acceleration of 2.35 meters per second squared. Again, the magnitude was asked, otherwise we should have indicated direction, which is down the slope. The next part of the question has to do with Newton's universal law of gravity. 2.2 states that a 2 kilogram rock lies on the surface of a planet. The acceleration due to gravity on the surface of the planet is 6 meters per second squared. So this gravity that they're talking about is the g for this specific planet. 2.2.1 asks to state Newton's law of universal gravitation. Two point two asks to calculate the mass of the planet if its radius is 700 kilometers. Now note that this is kilometers. The SI unit for physics is meters. Seeing as we have both the radius of the planet as well as its gravitational acceleration, we can use the following formula in order to solve the mass of this planet. The gravitational acceleration was given as 6. G is the universal constant equal to 6.67 times 10 to the negative 11. The mass of the planet is the unknown. And the radius was given as 700 kilometers. So remember, we need to take this to meters. So we times 10 to the power of 3 or times 1,000. And remember this square. Which gives us a total of 4.41 times 10 to the power of 22 kilograms.